Today we're talking about the determinant. The determinant is a number which determines if a matrix is invertible. We'll talk more about what an invertible matrix is tomorrow. For now, just know that every matrix has one, although we generally talk about determinants when it comes to square matrices, which are matrices that have even dimensions. Finding a determinant is one of those things where it's not particularly difficult in small matrices, but once you go to any matrix of size, it starts to get very difficult. So we will once again stick to smaller matrices with principles that we know will apply to bigger matrices. First, let's talk 2 by 2. We're going to go ahead and just write out a sample, a generic 2 by 2 matrix. Notice this time I used what kind of look like absolute value bars around the matrix. This indicates that we want to find the determinant. That's how we indicate it. Another way to do it would be to write something like DET in front of any matrix. Determinants are based on the diagonals of a matrix. In this case, notice we have our main diagonal, which I'm going to circle in green, and there is only one other diagonal in the matrix. It's this one that I'm circling in blue. I generally call that the other diagonal. To find the determinant, you simply take the main diagonal, multiply the elements together, and then subtract out the other diagonal. We'll do an example with numbers. This is number 5 from your homework. We have -4, -3, 1, 3. Well, our main diagonal is -4 times 3. And we subtract out the other diagonal, which in this case is -3 times 1. We get -12 minus -3, or -9. It's as simple as that. We get our number. It tells us some information about the matrix. Let's go ahead and try it with a higher order, meaning we'll go 3 by 3 this time. All right. Here in this matrix, we once again have our main diagonal, which I've been circling in green. Notice the elements in that this time are A, E, and I. However, that isn't the only diagonal that exists within this matrix. Notice we could have one that starts with B and F. Now here's where it gets kind of tricky. So notice we need to have one more element within this diagonal, so there's 3. We have the second column covered and the third column covered because B and F are in the second column. We have the first row and the second row covered because B is in the first row and F is in the second row, meaning the only element that isn't is represented in this row is G. So BFG is another diagonal of this matrix. There's one more. Similarly, C and DH form the third diagonal in the matrix. All right, those are all in the same direction as the main diagonal. Let's consider the ones in the other direction than the main diagonal. Well, the one that's kind of easy to see is CEG. We also have DB, which picks up the I. We also have FH, which will pick up the A. Those are all diagonals within the matrix, and once you write them like that, they're complete. So the formula for finding this looks a little bit more complicated, but you take all of the main diagonals and add them add them together, and then subtract out the other diagonals. So it looks something like this. AEI plus BFG plus CDH minus CEG plus DBI plus FHA. In total, that will give you the determinant of a matrix. I'm going to show you the way I would go about solving these problems in a way that's a little clearer to see. It's based on the same idea. I'm going to go ahead and do number 13 from the homework. 2, -2, -3, 5, 2, -4, 2, 4, -5. All right. I'm going to add some kind of ghost numbers. That's kind of what I call them. They're numbers that only we can see that we're going to add to this matrix to make it a little easier to see the diagonals. So I'm just going to go ahead and copy over the first two columns. All right. So all I did there is I just copied the first column and then the second column, so you can see them both over there. Now let's go ahead and put in our diagonals, and I think you'll see that they're much easier to spot because we can just go ahead and circle our first one. 2 times 2, -5, plus our next one. Hey, look, it looks like a diagonal this time. All the numbers are in a row. 5 times 4 times -3 plus our last one. 2 times -2 times -4. All right. Let's just go ahead and do some quick arithmetic. 2 times 2 is 4, times -5 is -20. 5 times 4 is 20, times -3 is -60. 2 times -2 is -4, times -4 is 16. So in sum, that will be -80 plus 16, which is -64. All right, let's go ahead and try the diagonals the other way. There's our first one. There's our next one. And our third diagonal. So we have 2 times 2 times -3 plus 2 times 4 times -4 plus 5 times 2 times -5. We go ahead, just do some quick arithmetic. That's -12. That becomes -32. And this becomes -50, correct? 5 times -5 is -25, times 2 is -50. So we add them together. We get 44 minus 50. So that becomes -94. So now we have -64 minus -94, which becomes +30. The trickiest part about this process, once you get the hang of it, is making sure that you keep your negatives and your positives straight. Other than that, it's just some simple arithmetic. Let me know if you have additional questions.